guys, back again today dissecting the code of the Sysex file. What do all those letters and numbers mean in that file? And why would you want to know what's in that file? Well, we use these Sysex files as ways to save patch settings. I could make a groundbreaking patch and be able to save that and then send that digitally to someone else. And sometimes you have trouble with these patches. The macros don't display right, or the name doesn't display right, and you'll need to go into the Sysex code and change that. So I have a Sysex file opened here, and we can see the code. And you can see in there that there's letters as well as numbers. But actually, these are all numbers. So the F's are actually numerals within the hexadecimal system. And so I'm going to take a few minutes just to explain the hexadecimal system versus decimal and binary. Why would you want to know that? Well, I had to learn it with reference to the 8086 chip. And after I understood hexadecimal, binary, and all that, it opened up a whole new world for me. And so if you don't know right now the difference between those different numbering systems, then hopefully this will open up that world for you. So this CPU of the Novation circuit, or any synthesizer, only understands ones and zeros. And we as humans don't do well with long chains of ones and zeros, being able to tell one from the other. But hexadecimal digits look very different to us. So a great way, I think, to understand binary and hexadecimal is to look at our own system and think of our own system a little differently than we normally do when we count and do multiplication and division. We don't normally think of our system as being in columns of 10 to an exponential power. But I think if we think of it that way, then it's very easy to go over to hexadecimal or binary. So if you start thinking of our current system that we use, the decimal system, in terms of columns, we have a column of 10 to the 0, and anything to the 0 power equals 1. So in all the different numbering systems, this is going to be the ones column. Even if you put 16 to the 0, which is the hexadecimal system, this column is still going to be 1 because, like I said, anything to the 0 power is 1. And then next you have the 10 to the first power column. And the exponential power is telling you how many times to multiply it. So here we're just multiplying 10. It's saying to take 10 one time. And so this is the tens column. Here it's saying 10 to the second power. So 10 times 10, it's 100. So this is the hundreds column. Let's take, for example, the number 127. It's going to have a 7 in the 10 to the 0 column. It's going to have a 2 in the 10 to the first power column. And it's going to have a 1 in the 10 to the second power column. Now, of course, I've put little formulas in these cells so that it would automatically calculate decimal, hex, and binary. But you can see what's happening in our numbering system. We normally don't think about it this way, but this is really what's happening. We're saying we have 1 unit of the 10 to the second power. 1 unit of 10 times 10 is what we're saying. So we've got 100 there. We've got 2 units of 10 to the first power, and we've got 7 units of 10 to the 0 power. And we add up 100, 20, and 7, we will get 127. It's 7F in hex, and there's a 0 missing here that Excel has dropped off the front of this. But it's 0, 111, and then 4 ones in binary. Okay, now let's take a look at hexadecimal. If we look at it in the same light that we were looking at the decimal system, the hexadecimal system is base 16, so it has a 16 to the 0 column, a 16 to the 1 column, and a 16 to the second power column. So let's put in an example number. Let's put in the 7F that we had up here and see what kind of result we would get with that. So So let's talk a little bit about the 16 digits of the hexadecimal system. In our system up here, the decimal system, we have 0 through 9. That's 10 digits in a base 10 system. In the hexadecimal system, it also has 0 through 9, but then they ran out of numbers. They didn't want to start putting 10 and 11 and having double digits there. So they needed one digit to represent 10 units, 11 units, 12 units, 13, 14, and 15 units. And so they used letters at that point. So after 9, 10 units in the hexadecimal system is an A. 11 units is a B, on up to F being the 15. So to make it, you understand it better, let me write the units in here in decimal so you understand what's going on. So we're going to put 7F in here and talk about what 7F means. So 7F would have 7 units of the 16 to the 1 column and F units of the 16 to the 0 column. But like I told you, F means 15. So let me put 15 in there so you understand the meaning of it. It means 15 units of the 16 to the 0 column, which is 1. I said anything to the 0 is 1. And 7 units of the 16 to the 1 column. And that comes out as 7F in hex. It means 112 decimal plus 15 decimal, and it's 127 decimal. 7F hex and the same in binary. Okay, we're in the isotonic editor that's free for the circuit here. But these patches that came with the circuit are kind of a starting point that you might make a good sound out of, or you can get the sounds that I've made. But let's go ahead and save this stock patch, and then let's make a change to it. Let's change the resonance of it and see how that's reflected in the Sysex file. The way you would save this stock sound to your desktop is by clicking on Save Single Patch to Disk. Then I'm going to change the resonance setting here and save it again, and we'll examine those two files and see what happened. I'm changing the resonance to 100, and I'm going to change the name to Sysex. Okay, I should tell you that this editor that I'm using to view and edit the Sysex files is called Hex Fiends, so if you want to get a hold of that. But now that we understand hex and some things about how we might read this file, let's go ahead and examine what is in the Sysex file. It starts out with a byte that says F0, and that is a universal byte that means start the Sysex. That's with any manufacturer, not just Novation. But then it says 002029, and that's the manufacturer number. That means Novation. And so only Novation will have that number. That way, if you're sending several Sysex transmissions at one time, Novation would disregard any but that number. They would know it was one of their products. The next byte is 01, and that means it's a synth. And then the next byte is 60, which means it's the circuit. And so there you can see you could even have a base station 2 or circuit sending messages, and it would know that this is meant for the circuit. And then down here at the end, you have F7, which means it's another universal number, which is going to mean in Sysex. And so all Sysex files should end in F7. But I have two Sysex files here. I have the original funk bass patch that we looked at, and then I said I was going to change the resonance. So I turned the resonance and I also changed the name, but you see the name didn't get changed. So like I was saying, the isotonic editor, the free editor, did not save the new name that I put on there. Even though I know this patch is called Sysex 2 and that's what I named it, if I'm going to send that patch to someone else and they're going to drag that onto their circuit, it will show the name there, and it could get them very confused if they're both called Funk Bass on there. So you will have to go into the Sysex and change that information. But if you have Hex Fiend as your editor, you can just edit over here without knowing the ASCII characters. I already know that if I type an A in here, that about right here at this bit in this file here, I'm going to see 41 in hex pop up because I happen to know that the ASCII code for an A is 41. So this is my old 8086 book that was copyright 1980, and even back then we had the ASCII codes that were in hexadecimal. You can see right here that an A is 41 hex. Okay, right there. I typed an A in and 41 popped up. I'll just delete out that funk bass right there, and I'll name it Sysex 2. But I see another problem that caused, and that is that this has shifted these bytes over, and it needs to end with the 40 F7 here in the same position. So the way you'll remedy that is go up here to where these zeros are and just add some zeros to that, and see how it shifts that over. And now that 40 F7 is right there in the byte that it's supposed to sit in. And I've also been able to change the name of this file to Sysex 2. And now if you send that to someone else, that's going to display properly. Now we made another change though. We changed the resonance. And so where would that be reflected? Well, Novation gives you the Circuit Programmer's Guide. And so this will tell you which byte is affected. That's the first number right there. It tells you the address of it, the default setting, and the min and max settings. But note that this is in decimal. So if you were going to change the settings in the Sysex file, you would have to know how to convert from decimal to hex at the very least. But I said I changed the resonance, so that would be down here, and they're saying that it's byte number 66 is the filter resonance and has a max of 127. Now I changed it to 100 with the editor, but that's going to be a different number in hex. So you might think, if you look at the Circuit Programmer's Guide, you might think that you're going to go to bit number 66 and you're going to see that change of the filter resonance. But no, that's not how it works. There's been an offsetting here due to putting in the start bit of F0 and putting in the manufacturer name and all that stuff. That used up some bits, and so you'll add 9 to any of these numbers. So we would look at byte 75 for the filter resonance. So over here on the left, you see that this is the decimal number actually and you can have it in hex as well just by clicking on it. But these are the decimal numbers, so we would look for number 75. So there's byte 64, 65, 66, 67. 75. So there's the byte that was affected when I changed the resonance setting. And if we go over here and look at the original setting, we see that it was 0C, and that now it has been changed to 64 hex. So I think I changed it to 100. So let's see what 64 hex is. So if I go to my calculator here, And if I put in 6-4 on the hexadecimal, sure enough, it's 100 in decimal. And that's what I set that resonance at. Okay, that about does it for my introduction to Sysex code using the Novation circuit as an example. And I did make 64 patches for the circuit and edited those in depth. And you guys have told me that you really enjoyed those, so I really appreciate that. So this isn't only useful on the circuit, it would be useful on any of the old synthesizers that maybe there's no editor for, and you want to edit the Sysex, make different patches and save them, things like that. And so I hope you find this useful.